Hi. So we'll continue with this course on integrals. This is question number 26. Integral of sine 3 theta plus sine theta multiplied by cos theta and e power sine theta, right? So now we'll use this identity here. Sine 3 theta plus sine theta will become 2 sine 2 theta cos theta. And therefore this becomes 2 sine 2 theta cos square theta e power sine theta d theta, which can be written as 4 sine theta cos cube theta e power sine theta d theta. So basically, I'm using the double angle formula here. And now what I can do is I can easily take sine theta as t here because this is cos square theta can be written like this. And there is one extra cos theta left, right? In cos cube theta, I have written as 1 minus sine square multiplied by cos. So if I take sine theta as t, you will get here 4t, 1 minus t square, e power t, and cos theta d theta becomes your dt, right? So this integral becomes 4t e power t minus 4t cube e power t dt, right? So which is basically I1 minus I2, and you do it separately. So integral of t et 4 times, this part is your I1 minus 4 times integral of t cube et dt. And both of these can be done by integration by parts. So for example, this one will become t into et minus et, so which is equal to t et minus et. And this part you'll have to do multiple times, but it is very easy. So for example, first one I will do t cube et minus integral of et into 3t square. Now do this by the same by parts method. It will become t et, and then you know the answer for t et, right? So after this point, it is just a lot of simplification. You can do that yourself. The idea here was simply using the right trigonometric formula and putting the substitution sine theta is equal to t, right? Let's move on. This is question number 27, and this talks about if sine x to the power minus 3 by 4 cos x to the power minus 21 by 4 dx is equal to tan x power a1 by b1 plus tan x power a2 by b2 plus tan x power a3 by b3 plus c. Then you have to basically find these constants a1, a2, a3, b1, b2, b3. You have to find the value of a1 plus a2 plus a3 plus b1 plus b2 plus b3 whole divided by 2 and take the GIF of that. That is what the question is asking. Now, basically, we just have to integrate it. If we get the integral, we'll be able to find a1, b1 and stuff, right? So here, notice that this is of the form sine power mx cos power nx, but m plus n is equal to negative integer, which is minus 6, right? Whenever m plus n is minus 6, generally tan x is a good substitution. Tan x is equal to t, or cot x is equal to t could be good substitutions whenever m plus n adds up to a negative integer. So that is a standard technique. You'll find this in any textbook that you see. So let's see how we can use this, right? So this is actually becoming integral of sin x to the power minus 3 by 4 divided by cos x to the power minus 3 by 4. And if I put minus 3 by 4, I should multiply here also by minus 3 by 4. So it will be minus 24 by 4, which is equal to minus 6, right? Minus 6, minus 24 by 4. So this is equal to integral of tan to the power minus 3 by 4x and cos to the power minus 6x, which is equal to tan to the power minus 3 by 4x by cos to the power 6x, which is basically sec to the power 6x, right? Okay, so now the integral is easy because you have got a sec power 6. So I can write it as tan power minus 3 by 4x and sec power 4x multiplied by sec square x dx, right? And sec power 4x I can convert as tan to the power minus 3 by 4x 1 plus tan square x whole square, and there is a sec square x dx, right? Now if you can take t is equal to tan x, you'll get integral of t power minus 3 by 4 1 plus t square whole square and dt. This is an easily doable integral because what you will do is you'll expand the whole integral in terms of t, right? So what I will do is integral of t power minus 3 by 4 1 plus t power 4 plus 2t square, and this is dt. This becomes t power minus 3 by 4 plus t power 13 by 4 plus 2 t power 8 by 4 minus 3 by 4. So 5 by 4 dt. And each integral can be done separately and you'll get powers of tan x. So after this point, you can simplify and get your a1, b1 and stuff. At the end, you have to add up all these constants, divide by 2 and take the GIF to get the answer, right? So you can finish this off yourself. Let's move on. This is question number 28. If integral of 1 plus x cos x minus sin x dx divided by x plus sin x plus cos x whole power half multiplied by x minus sin x plus cos x whole power 3 by 2. This integral, basically we have to find the integral. So let's try to think about what we can do here. If we take this as t, I will get 1 plus cos x minus sin x, but there is 1 plus x cos x minus sin x. If I take this as t, I will get 1 minus cos x minus sin x. Again, it's not matching the top part, right? Okay, so let's think about what else we can try here. Okay, what we can do is this is root of x plus sin x plus cos x, and this is 3 by 2 power. So I can put a by root of x minus sin x plus cos x, and on top here it will be x minus sin x plus cos x whole square, right? And here we have 1 plus x cos x minus sin x dx. So basically what I'm trying to do here is to convert this part into a square, because 4 by 2 will be power 2, and just get one big root here, right? I'm hoping that x plus sin x plus cos x by x minus sin x plus cos x I can take as t or something. So if I try to take this as t, okay, actually I should not take it as t because then the root will remain. So I should take it as t square, right? If I take it as t square, then I'm hoping that some dx, this part will handle itself with dx. So let's try the differentiation of this once. So this will become 2t dt is equal to differentiation of the top part is 1 plus cos x minus sin x multiplied by x minus sin x plus cos x minus differentiation of this is 1 minus cos x minus sin x multiplied by x plus sin x plus cos x, and the whole thing is divided by x minus sin x plus cos x whole square, and there is a multiplication with dx, right? So hopefully this will simplify out to something similar to this, because already this by dx square is, that part is coming. This is matching this, right? So let's try to see the simplification here. It becomes x minus sine x plus cos x plus x cos x minus sine x cos x plus cos square x minus x sine x plus sine square x minus sin x cos x minus sin x cos x, and then there is a minus, and inside we have x plus sin x plus cos x, and we have minus x cos x minus sin x cos x, and minus cos square x, and then we have minus x sin x minus sin square x and minus sin x cos x. This is the simplification. Now notice here that this is minus sin x plus cos x. Okay, okay. So this minus x cancels this x. This minus sin x doesn't cancel. Minus cos x cancels. This one plus x cos x doesn't cancel. Plus sin x cos x cancels this one. Plus cos square x doesn't cancel. Plus x sin x cancels this one. Plus sine square x doesn't cancel, and plus sin x cos x cancels this one. So what we are left with here is minus sin x plus x cos x plus cos square plus sine square, which is plus 1. And you have plus x cos x from here and plus cos square plus sine square, which is plus 1. So we get 2 plus 2x cos x. And I should have got an extra sin x. There is a minus sin x here, minus sin x here. So minus 2 sin x, minus 2 sin x. So we get 2 times 1 plus x cos x minus sin x here, which notice that it fits this perfectly, right? So what we get is 2 times this by this denominator dx is equal to 2t dt. So t dt will be equal to this whole part, right? So now what we can do is actually we can write the integral as integral of t dt by root of t square, which is t, right? So it becomes just integral dt and the answer is just t. And t was what for us? T was root of this. Root of this was t. So that will come out to be your answer, right? So again, the question looks hard, but like a simple step here, like take one common root and make it square, and then take that square root part as t, right? That simple step helps everything work out, because the question is designed nicely in the sense that your derivative of your t will be your dt and stuff. It will match. So you need to be on the lookout for such questions and the lookout for such substitutions. You just have to try things. Like if you try this is a natural thing to try, and once you get it, you'll realize what is happening. So let's move on. Question number 29. This question is this one: integral x power 6 plus 7x power 5 plus 6x power 4 plus 5x cube plus 4x square 3x plus 1 into e power x dx. This is what we have to figure out, right? So we have to find out this integral. We will use our standard integral, this one, and we'll try to get it in that form. So this is equal to e power x fx, as we have seen before also. So let's try to fit this in that form. So I'll take x power 6, and what is the derivative of that? It is 6x power 5. So these are together. So what is left here? I'm left with x power 5, right? Because there is 7 here. X power 5 plus 5x power 4. What is left here? There's an x power 4 left here. So x power 4 plus 4x cube. Again, x cube is left. X cube plus 3x square. X square is left, plus x square plus 2x, plus again x is left, so x plus 1. So the whole thing can be written like this. So if it is an integral now, each of these can be separated into its separate integral. We'll get e power x into x6 for the first answer, e power x into x5 plus e power x into x power 4, x into x cube, power x into x square plus e power x into x, right? So the answer for us is simply e power x, x power 6 plus x power 5. This is the answer for this integral. So notice how we got it. We are just repeatedly using this property, this standard integral. We are trying to group the terms in such a way that it works out here, right? So grouping the terms in that way, you'll realize that all of it is designed in a way that it immediately becomes fx plus f dash x in each of those terms. Okay, let's move on. Question number 30 is integral of sine 2x plus 2 tan x by cos power 6x plus 6 cos square x plus 4 into dx. Okay. So hopefully we'll try to convert this into like some formula which helps us get the integral. Like ideally, if there is a cos, I have to divide by some power of cos. That is the standard method. So let's write the first part as the numerator as cos. So it is 2 sin x cos x plus 2 tan x divided by cos power 6x plus 6 cos square x plus 4 dx. So here there is a power of 6, so I can divide by cos power 6 here, up and down. If I do that, I will get 2 sin x cos x by cos power 6x plus 2 tan x into sec power 6x divided by, this becomes 1 plus 6 sec power 4x plus 4 sec 6x, right? Dx. Now notice that the top part is just 2 tan x sec power 4x, right? One cos cancels, one cos goes to make a tan, and 4 cos's are left in the denominator, plus 2 tan x sec power 6x divided by 1 plus 6 sec power 4x plus 4 sec power 6x. This is the integral. And if I take this part as t, what comes? This becomes 24 sec cube x into sec x tan x plus 24 sec 5x into sec x tan x. So sec power 4x tan x and sec power 6x tan x. So this is a simple substitution now. This becomes your t, and the top part 24 times this thing dx is equal to dt. So 2 times this thing. Here you have 2 times dt by 24, right? So you get 1 by 12 dt by t. So 1 by 12 ln t is your answer. 1 by 12 ln t, and t is what? 1 plus 6 sec power 4x plus 4 sec power 6x, right? That comes out as your answer. Again, simple substitution here. However, the method was, if you have powers of cos, divide by the highest power of cos, because that will try to convert it into sec. And if you can get everything in terms of tans or secs, then it is possible that the integral might be doable, right? Okay, the next one for us is question number 31. And let's look at this one. This is basically integral of f dash x gx minus g dash x fx dx divided by fx plus gx root over gx fx gx fx minus gx, something like this. Okay, we have to find this is equal to apparently root m tan inverse root over fx minus gx by n gx. What we have to find is m square plus n square. Okay, so this form on top suggests that I should divide by gx square on top, like, because this is like a quotient rule, right? If I do this, gx minus g dash x f of x by g square x gx whole square. So I will have to do the same in the denominator as well. So I will do fx plus gx by gx, and here inside I will do gx into fx minus gx by gx whole square, because when you go inside with a gx in the root, it becomes gx whole square. So this integral is looking like integral of f of f dash x g minus f of x g dash x by gx whole square dx divided by fx by gx plus 1 and root over fx by gx minus 1, right? Great. So I can take fx by gx as my t, because this part will become your dt, right? So because fx by gx, derivative of fx by gx by quotient rule will be equal to this thing. So my integral will become integral of dt by t minus 1 root and multiplied by t plus 1, right? So to solve this integral, I simply do t minus 1 is equal to u square. So dt is equal to 2u du, and I get 2u du on top and u here, and t is equal to u square plus 1. So this will become u square plus 2, and this cancels here. Get 2 outside, du by u square plus 2. This becomes 2 by root 2 tan inverse u by root 2, and u is root t minus 1. After that, you put the values, you get m and n. It will come out, m and n will come out as 2, and n square plus n square will be 8, right? So the idea here was, as soon as you got this expression looks a lot like differentiating fx by gx. The only thing missing was by gx square. So I added that, and I did the same thing both in the numerator and the denominator. And once I did that, I was able to take fx by gx as t. Once you do that, the integral simplifies quite nicely, right? So that's it for now. We'll continue with more problems. There are like approximately like 6-7 more videos that should be there in this chapter. We'll cover everything from indefinite to definite integrals and all types of problems. And hopefully that will be very useful for you for JEE Advanced. See you next time.